Imagine a world where machines can teach themselves to improve, to adapt, to overcome challenges, and to achieve goals. What might that look like? In the realm of artificial intelligence, this isn't a hypothetical scenario. It's the exciting reality of reinforcement learning. But what exactly is reinforcement learning, and how does it work? Reinforcement learning, or RL, is a type of machine learning where an agent learns to make decisions by taking actions in an environment to achieve a goal. Picture a mouse in a maze. The mouse doesn't know the layout of the maze or the location of the cheese. It learns by trial and error, running into walls, backtracking, finding new paths, and eventually reaching the cheese. In this scenario, the mouse is the agent, the maze is the environment, and the cheese is the goal. The agent interacts with the environment and learns from the consequences of its actions, adjusting its behavior to achieve the goal. Now let's take a step further and introduce another concept: deep Q learning, a subset of reinforcement learning. Deep Q learning combines the power of deep learning with the strategy of Q learning. Here, Q stands for quality. This algorithm assesses the quality of a particular action in a given state, aiming to find the best action that would yield the highest reward. In a game of chess, for instance, deep Q learning would evaluate the quality of each possible move, considering the current state of the board. The algorithm calculates a Q value for each move, representing the expected future reward of that move. The move with the highest Q value gets picked. Over time, as the algorithm plays more games, it refines its Q values, improving its game strategy and becoming a formidable chess opponent. But where does deep come into play? It's a nod to deep learning, a type of machine learning that uses neural networks with many layers. These layers enable the algorithm to process vast amounts of data and learn complex patterns. In deep Q learning, a neural network takes the place of the traditional Q table, handling the task of estimating Q values. Now let's consider a real-world application of reinforcement learning and deep Q learning: robotics. In the field of robotics, an RL-trained robot can learn to perform tasks by interacting with its environment, just like our mouse in the maze. It could learn to pick up objects, navigate around obstacles, or even assemble items. Deep Q learning can help it refine its skills, becoming more efficient and precise in its tasks. In summary, reinforcement learning is a powerful tool in artificial intelligence, enabling machines to learn from their interactions with the environment. Deep Q learning takes this a step further, combining deep learning's pattern recognition with Q learning's strategic decision-making. Together, they're revolutionizing fields from gaming to robotics, pushing the boundaries of what machines can achieve. And so we circle back to our initial thought. A world where machines can learn, adapt, and improve isn't a distant sci-fi future. It's here, it's now, and it's incredibly exciting. Reinforcement learning and deep Q learning are making it possible, turning the hypothetical into reality.